Hey everyone, so welcome back to another installment of Mr. Cox Teaches, or Mr. Cox Does These Practice Problems. So I hope that your e-learning is going well. I hope that if you have questions, you feel like you can reach out to me and send me an email or whatever. Alright, so we're going to continue to do these ideal gas law practice problems. So I'm going to do numbers 6 through 11, so this video might be a little bit longer than the other ones. Alright, so remember this is the formula, PV equals nRT. And they're all multiplied together. Okay? So P is pressure, and pressure has to be in this unit called atmosphere. So there's a ton of different units for pressure, like millimeters of mercury or kPa or something like that. But to use the ideal gas law, the pressure has to be in atmospheres. Alright, the volume, in order to use this formula, the volume has to be in liters. And it wasn't a problem on the last sheet, but on this sheet it is going to be a new thing where you have to do some conversions. Alright, so N is number of moles. Alright, and that has to be in moles. Alright, the R is this number, 0.08206. It's just a constant. And T is the temperature, and it has to be in Kelvin. Okay, temperature in Kelvin. Alright, so let's do number 6. It says, how many moles of a gas, of CO2 gas, would occupy 33.7 liters of volume at a temperature of 251 Kelvin and a pressure of 1.30 atmospheres? Alright, so this first one, liters, that's going to be your volume. So I'm going to fill that in for the V here, so 33.7 liters. Alright, some people may ask, well, how did you know that was liters? Well, capital L is the abbreviation for liters. Alright, at a temperature of 251 Kelvin, alright, so temperature, this is going to be temp. Alright, so that's 251 Kelvin. Alright, the pressure is 1.30 atmospheres, so 1.30 atmospheres, and you can abbreviate that ATM if you want. Alright, and remember the R is always going to be this number, 0.08206. And then the N is going to be your X. It's going to be your unknown because it says how many moles of CO2 gas. Okay? So let's plug it into this formula up here. Alright, so the P is going to be 1.30 times 33.7. And then on the other side, you're going to have N, which is X, times the 0.08206 times the temperature in Kelvin, which is 251. Alright, so we didn't have to convert to Kelvin because it was already in Kelvin, so you didn't have to add 273 to that number. Alright, so now I'm going to take out my calculator here, and I'm going to multiply these two numbers together on the left side here. So I'm going to do 1.30 times 33.7. That gives me 43.81. Alright, and then on the other side, I've got X times 0.08206 times 251. So I'm going to multiply those two numbers together, 0.08206 times 251. And that gives me 20.597, so I'm going to round this to 20.60. But I've still got this times X because the X is still there. Alright, to solve for X, what I'm going to do is I'm going to divide by whatever is with the X on this side to get the X by itself. So I'm going to divide by 20.60 on both sides. Alright, over here, this is just 1, so we're just left with X. And then I'm going to do 43.81 divided by 20.60. And that's going to give me 2.13. Alright, so if you look back up here, the X is the number of moles. So X is going to be equal to 2.13 moles. Alright, so there you go. That was pretty easy. Alright, let's move down here and let's go on to the next one. Alright, so it says, what is the temperature of 3.45 moles of a gas at a pressure of 5.60 atmospheres and a volume of 12 liters? Alright, so reading this again, we've got what is the temperature, so I'll get to that in a second. So 3.45 moles, that's going to be N. So I'm going to fill that in here to 3.45 moles, goes there. at a pressure of 5.60 atm, and atm stands for atmosphere, so it's going to be 5.60 atm. The volume is 12 liters because it says and a volume of 12 liters. So the V is going to be 12.0 liters. Alright, the R is our constant, 0.08206. And the temperature is going to be X because it says what is the temperature. So we don't know. Alright, so P, we're going to plug all these numbers into this formula. PV equals nRT. So the P is going to be 5.60. We're going to multiply that times the volume, which is 12.0, equals the other side, which is 3.45, the N, times 0.08206 times X. Okay? So now the first thing I want to do is I'm going to do 5.60 times 12. So let's move this over a little bit. So I've got 5.60 times 12.0. Alright, that gives me 67.2 equals 3.45 times 0.08206. Alright, and that gives me 0.28 times X. Because remember, the X is still there, even though you can't see it, it's like trailing off my paper. The X is still there because we don't know what it is yet. Okay? So, let's multiply, or let's divide. So we're going to divide both sides by this 0.28. Alright, so divide this side by 0.28 as well. Alright, so on this side, we'll just be left with X, because 0.28 divided by 0.28 is going to be 1. It's going to be itself. Alright, so now we're going to do 67.2 divided by 0.28, and that is 240. Okay. So, let's go back up here. The X was our temperature. Alright, so it's going to be X equals 240. And the unit, since it is temperature, is going to be Kelvin. So 243, or 240 Kelvin. It doesn't say they want it in Celsius, so you can just leave it in Kelvin. So it's going to be 240 Kelvin. Alright, let's move on to the next one, number 8. Alright, and again, if you get behind, you get lost, or you want to rewind this video, you can always go back to the very beginning or back to the the previous problem or whatever, and you can work with me. Alright, so P times V equals N times R times T. That is the formula for the ideal gas law that we've been using. Alright, so it says a sample of nitrogen gas is at a pressure of 1.20 atm, a volume of 30 liters, and a temperature of 87 degrees Celsius. How many grams of nitrogen gas are in this sample? Alright, so let's read this again. It says a pressure of 1.20 atm. So P, the pressure, is going to be 1.20 atm, which stands for atmospheres. A volume, which is the V, of 30 liters, and a temperature of 87.0 degrees Celsius. Okay, so we already know that the R is also 0.08206. Alright, so this N is going to be our X. Alright, so it says how many grams of nitrogen gas are in this sample. So one of the ways that you could have known that N is the unknown is you could have said, okay, well, if I have moles, I can convert the moles of whatever this is, and it's nitrogen gas, to grams by multiplying by the molar mass. But a lot of you probably were just like, I don't know. So you fill in whatever you have. A lot of you probably forgot that this R is always given to you. It's the 0.08206. So just by the process of elimination, you could have figured out that N was going to be the X. Okay? So there is one thing that I need to fix, though. This temperature is in Celsius, degrees Celsius. So I'm going to have to turn it into Kelvin. And to do that, I'm just going to add 273. Alright, so 87 plus 273, that is going to give me 360. Alright, so 360, and that is now in Kelvin. Alright, so let's plug this into the formula up here at the top, the PV equals nRT formula. I don't know what happened to this R, but it looks terrible. Alright, so we've got P, which is 1.20, times 30, because that's the V. 1.20 is the pressure. The volume is V, it's 30 liters. Alright, we're going to have that equal to the N, which is our unknown. We don't know what that is. X times the constant, 0.08206, times the temperature in Kelvin, which is 360. Alright, so now in my calculator, I'm going to do 1.20 times 30. That is 36. Alright, and then on this side, I'm going to do these two numbers multiplied together times x. So 0.08206 times 360 equals 29.54, and I'm just rounding to two decimals. Alright, times x. So now what we're going to do is since this is multiplication, we're going to do the opposite of multiplication. We're going to do division. So we're going to divide both sides by whatever is with the x to get the x by itself. Okay. And now in my calculator, I'm going to do 36 divided by 29.54. And I got 1 point, and this is 218. So I'm going to round that to 1.22. And then over on this side, we've just got x. Alright, so we've got x equals 1.22 moles. Alright, so we're done, right? That was awesome. That was great. Wait, no. How many grams? Oh, this is annoying. Alright, so we have moles. We can get it to grams doing this. And I know you're going to love this. Draw the x and then draw the fraction bar. Alright, I know you're enjoying this because this is just converting moles to grams. Alright, so we're going to put moles on the bottom because that's the word we just had right here. So moles goes onto the bottom. And we're trying to convert it into grams. What number do you think should go with moles? A 1 always goes with moles. And now we need the molar mass for whatever this is. And if you look back up here at the top, it says a sample of nitrogen gas N2. Alright, so this is going to be N2. And if you look at a periodic table, you'll see that the molar mass for nitrogen, just one of them, is 14.0067. But we're going to have to multiply that times 2 because there's two of them. So 14.0067 times 2. That is going to be 28.01. Alright, and then you're going to take that number and put it right here. So now we're going to multiply across the top and divide by the bottom. So we're going to do 1.22 times 28.01 divided by 1. Alright, so now 1.22 times 28.01, that gives us 34.17, and it's in grams. Alright, so this is actually your final answer. Alright, so if you got lost there with me doing all of this craziness, we plugged all these numbers into the ideal gas law, and we got out the number of moles. So this 1.22 here is in moles. But they didn't want moles. They wanted grams. And if we have moles, we can get to grams by multiplying the number of moles we have by the molar mass. So I looked back up here at the top, and I read it says a sample of nitrogen gas, which is N2. I say, okay, there's N2. Now I have to find the molar mass for N2. So I looked up what just one nitrogen weighs, which is 14.0067, multiplied it by 2, and got this 28.01. And then I plugged that number up here into the conversion for grams. And I got 34.17 grams. And that's your overall answer for this. Okay? Whew, that was a lot, right? That was a lot. Alright, hopefully the next couple aren't that difficult. Alright, so number 9 is saying, what is the volume of a container containing 7.59 moles of krypton gas at 100 kPa and 30 degrees Celsius? Alright, so it says, what is the volume, we'll come back to that in a second, containing 7.45 moles. Alright, so since it says moles here, that has to be the N, 7.59 moles. Alright, of krypton gas at 100 kPa. So 100 kPa, that is going to be a pressure. But I see that as a problem. Let me fill this in and I'll tell you why. Alright, in order to use the ideal gas law, the pressure has to be in atmospheres. So this is a problem, so we're going to have to convert this here in a second from kPa into atmospheres, and I'll show you how to do that. Alright, 30 degrees Celsius is a temperature, so this is going to be 30 degrees Celsius. We're going to have to convert that into Kelvin as well. Alright, so the pressure up here, to convert this 100 kPa into atmospheres, we're going to draw the X, draw the fraction bar like that. We're going to put the unit that we just wrote on the bottom. Alright, so the unit that's right here goes onto the bottom. And the unit that we're trying to go to, which is ATM, goes on the top. So now we're going to need a conversion factor. We're going to need how many kPa are in 1 atmosphere. Because remember, 1 goes with the atmosphere. Alright, so how many kPa are in 1 atmosphere? If you guessed 101.3, you would be correct. Alright, so now in my calculator, I'm going to do 100 times 1 divided by the 101.3. So let me move this over. So I'm going to do 100 times 1 divided by 101.3. And that gives me 0.987. So I'm going to round that to 0.99. So 0.99. And that is now ATM. Alright, so to reiterate that, we are going to do, if we want to, we are going to fill in this 0.08206 to that, because we always know what the R is. And then the volume is going to be our X, because it says what is the volume. Alright, so there's one other thing that is wrong here. I see this is 30 degrees Celsius, and in order to do these gas law problems, this has to be Kelvin. So I'm going to add 273 to this. So 30 plus 273, let me do that on my calculator. 30 plus 273, that is going to be 303. Alright, and that is now in Kelvin. Okay, so now what you want to do is you want to plug in the values into the PV equals nRT up here. But we're going to have to use the ATM here. So this is 0.99, so that's the pressure. So 0.99 times the volume, which is X, we don't know what it is. It's going to be equal to 7.59, because that's the N, times 0.08206, because that's the gas constant, that's the R, times the T, and it's going to be the Kelvin temperature, which is 303. Alright, so on this side we've just got 0.99 times X, or 0.99X. That's going to be equal to all three of these numbers multiplied together. So I'm going to do on my calculator, I'm going to do 7.59 times 0.08206 times 303. Alright, and wow, that's a gigantic number. Alright, so it's going to be 188 points, looks like 72. Okay, so now to get the X by itself, you want to do the opposite. So if this is multiplication, we're going to divide by whatever is with the X. So I'm going to divide by 0.99 on both sides. So now on my calculator, I'm going to do 188.72 divided by 0.99. That is going to be equal to 190.6262, so I'm going to round this to 0.63. Alright, if you look back up here at the top, it is a volume, and since this is a volume, it's going to have to be what unit? You probably guessed it, it is liters. Great job. Alright, so liters goes there, and you're done with that problem. Alright, so if you're getting a little tired of doing these, press pause, I'll still be here. You can come back and you can work on some more of these gas law problems. Alright, so there are two left, and I'm going to go up here to the top of this one. Alright, so here again is the formula. P times V equals N times R times T. Okay, so remember the pressure has to be in the unit atmospheres, or ATM. Alright, the volume has to be in liters. The N is number, and that just stands for number of moles. So it can't be grams. And I see that's wrong with this one right here. Alright, R is the number, 0.08206. And then finally is the temperature, and it has to be in Kelvin. Okay, so it says a 20.0 gram sample of hydrogen gas has a volume of 40.55 liters and a temperature of 67 degrees Celsius. What is the pressure of the gas? Alright, so the first thing that I see is 20 grams. I don't know where that goes, so I'll come back to that later. Alright, so it has a volume of 40.55, so 40.55 is going to go there. It's in liters. Alright, and a temperature of 67.0 degrees Celsius. What is the pressure of the gas? Alright, so we already know the R is 0.08206. It says, what is the pressure of the gas? So the pressure here is going to be X. Alright, so that means that this N, or the number of moles, we also don't know it, but we have this piece of information, this 20 grams. And some of you might be thinking, oh man, we're going to have to convert the grams into moles, aren't we? And you are correct. We're going to convert grams into moles. Alright, so I did 20 grams, I drew the X, and then I drew the fraction bar like that. I'm going to put grams on the bottom because I just wrote it right here. It goes onto the bottom. And the top is going to be whatever unit we are trying to go to. And in this case, it's going to be moles. Alright, so if you already haven't figured this out, the number that goes with moles is a 1. Alright, and it says a 20 gram sample of hydrogen gas. The chemical formula for hydrogen gas is actually H2. So to find the molar mass for H2, the number that's going to go here, what you're going to divide by, you're going to take the number for just one hydrogen from the periodic table, and it's 1.008, and I rounded that, and you're going to multiply it by how many there are. So you're going to multiply it by this number, which is 2. So 1.008 times 2, get out your calculator, 1.008 times 2 is going to be 2.016. Alright, so then you're going to take that number here, and move it up to here, 2.016. Alright, so in your calculator, you're going to do this number 20 times 1 divided by 2.016. So 20 times 1 divided by 2.016. Alright, and that gives me, I'm just going to write it right here, equals 9.92, and that's in moles. Alright, so now we have all the things that we need. We have all of the values for the PV equals nRT equation. Alright, we have the volume in liters. We've got the N, which is the number of moles, which is right here. We've got the R value, which is a constant, never changes. And then we've got the T, but uh-oh. This is in Celsius. We can't have Celsius, so we have to convert it into Kelvin. To convert it into Kelvin, we're going to add 273. Alright, so 67 degrees, 67 plus 273. That gives me 340, and that is in Kelvin. Alright, so if I'm going too fast for you, just slow down the video, go back, rewatch it, maybe you didn't understand something, rewatch the video, and then you can catch back up with me. Again, I'll still be here. Alright, so we're going to plug in these values that we have into the PV equals nRT equation. So P times V equals N times R times T. Alright, so P is going to be X. It's what we don't know. We're going to multiply that times 40.55 because that's the volume. Alright, the N is going to be the moles number that we calculated up here. So the N is actually going to be 9.92. So I'm going to put 9.92 there. I'm going to multiply it times the 0.08206 times 340, because that's the temperature in Kelvin. Alright, on the left side, we've got X times 40.55. There's nothing really we can do with that. So I'm just going to do X times 40.55. Alright, on the other side, we've got three numbers we can multiply together to get some larger number or smaller number. Alright, so I'm going to multiply 9.92 times the 0.08206 times the temperature, which is 340. Alright, and that is going to equal 276.77. Alright, so now to get this x by itself, it's multiplication here, so we're going to divide to get this x by itself. So I'm going to divide by 40.55, and I'm going to do that on both sides. So when I do this over here, I'm just left with 1, I'm just left with x. And then on the other side, we're going to do the 276.77 divided by 40.55. Alright, and that gives me 6.8, and it's 2 5s, so the 5 will make the 2 go up, so it's going to be 6.83 And what unit should it be? Let's look up here. This is a pressure, and if it's a pressure, it has to be in ATM or atmospheres. So it's going to be 6.83 ATM or atmospheres. Okay? So this is your overall final answer. The pressure is going to be 6.83 ATM or atmospheres, however you prefer. Alrighty, let's go down and do the very last problem. This one is number 11. It says an unknown quantity of gas, and I'm assuming by quantity they're meaning moles, has a pressure of 1500 torr, ew, that does not sound right, a volume of 25 liters, and a temperature of 30 degrees Celsius. Calculate the moles of the gas. Alright, so they do say it's calculate the number of moles. Alright, so this N is going to be our X. It's going to be what we don't know because it says calculate the moles of the gas. Alright, an unknown quantity of gas has a pressure of 1500 torr. And this is a problem. Why is it a problem, you may ask? Because in order to use the formula, the PV equals nRT formula, the pressure has to be in atmospheres. So we're going to have to convert this 1500 torr into that. So I'll do that in a second. Alright, a volume, which is the V here, of 25.0 liters. Alright, and a temperature of 30 degrees Celsius. And that's also not good because we're going to have to convert that into Kelvin. So the R value is always this 0.08206. And that's pretty much it for that. Alright, so let's go back to this pressure here. It's 1500 torr. Let's draw an X and then a fraction bar. We're going to convert this into ATM. So I'm going to put the word that I just wrote over here onto the bottom. The torr goes onto the bottom. And then ATM is going to go right here. Alright, so there's 1 atmosphere. How many torr are in 1 atmosphere? And you may be thinking, oh, good golly gosh, I have no idea. That's fine. I got you. 760. Alright, so what you're going to do is you are going to do 1500 times 1 divided by 760. So let's get out my calculator. So I've got, I don't know if you can see that or not, 1500 times 1 divided by 760. And that gives me 1.97. So I'm going to put 1.97 ATM there. Alright. And then the last thing we need to do is we need to fix this temperature down here. It's 30 degrees Celsius. We're going to add 273 to that to get it into Kelvin. So I'm going to get out my calculator. 30 plus 273 gives me 303. Alright, let's set up the formula. So the formula is P times V equals N times R times T. Alright, so let's do the ATM number as our pressure. Alright, so it's going to be 1.97 times 25, because that's our volume, our liters. Alright, it's going to be equal to X times the R value, which is the 0.08206, times the temperature, which is in Kelvin, times 303. Alright, so 1.97 times 25, so 1.97 times 25. I just typed that into my calculator, just like that. Alright, I got 49.25, so I'm going to put 49.25 there. Alright, and then on the other side, the right side, I'm going to have these two numbers multiplied together times X. So let's do on my calculator, let's do the 0.08206 times 303. Alright, that gives me 24.86 times X. Okay? So now we've got 24.86 times X on this side, and we've just got 49.25 over here. To get the X by itself to see what it equals, we're going to have to do the opposite of multiplication, which is division. So we're going to divide by 24.86 on both sides, because remember what we do to one side, we've got to do to the other side. Alright, so on the other side, the right side here, we're just going to be left with X, or something equal to X. So now I'm going to plug this into my calculator. I'm going to do 49.25 divided by 24.86. Alright, so see there, 1.98 equals X. So 1.98 equals X. Alright, and if you look back up here at the top, okay, if we're looking for what units it should be, we've got N, and N, remember, stands for number of moles. Alright, so 1.98 moles is going to be your answer. So 1.98 moles. And there you go. There's the overall answer. Alright, so I hope that you learned how to do this, or maybe I cleared up some confusion. Anyways, if you have any questions, please let me know. Please reach out through Google Classroom or, email me. I'm always trying to help. Have a great day.